All right, we are back. So where we left this last time was we were we had it working pretty well um, on a totally flat plane. And then we kind of mucked it up by starting to get really complicated with terrain. So we're going to try to work through that. So basically, in cases where the terrain can kind of be all over the place, you can think of, like, if we watch, take a screenshot here of Final Fantasy Tactics. And here's a good example where, we have all these different shapes, and so people can kind of jump up to this tile, but they can't go from maybe here to this tile. Like, that would be too big of a jump. So maybe let's say you can jump, at most one tile. It looks like they have, like, a lot of these games have, halfway tiles too, so that's another thing to consider. But you can jump up to a half tile or a full tile. And so that creates a sort of adjacency kind of graph. There's also complexity around kind of like, can you shoot an arrow from right here, like in some high parabola, and hit someone up here, even if there isn't a direct line? I don't know if I'm going to worry about that. But what we're going to try to do today is to tackle, being able to support scenarios like this. There's one level in Final Fantasy Tactics where, yeah, this is it. This battle on the bridge is really interesting. See if I can just get the screenshot. Yeah, so you're on this bridge, and people can actually be below the bridge. So you can even have two people right on top of each other. The way they handled this on PlayStation was, if you had your mouse on the bridge, it would just alternate between being on the bridge and below the bridge, and you would pick which one you wanted. Because you could end up in a situation where, especially a flying character, it could move. He could either be on the bridge or below the bridge on his turn. With touchscreen, you don't have to worry about that because you're touching, you're casting a ray directly on that square. But yeah, so let's take a look at what we have so far. We have our program. Our program creates a little height map. I'm using a triangle function. We can click into this. So this triangle function looks like this. At 0, it's 0. At 1, it's 1. At 2, it's 2. Oh no, at 1, it's 2. So it goes from 0. Oh, actually, let me fix this. I think the period is still 4, but the amplitude, I think, needs to be 1. So if we look up triangle function, we get the triangle wave. This is the equation for a triangle wave. We actually want the amplitude to be half of what it is. It looks like it's increasing at too big of a rate. Okay, let's fix that. So everywhere we see an A, I need to change that to a 1. So this goes to a 1. This goes to a 1. Those are the only two places. Yeah, okay, let's recalculate that. Whoa, okay, that was not right. That's pretty cool looking though. Okay, let's go back to a 2. What did we do wrong here? So if you have an amplitude A and a period P, oh, I see. Actually, this should be a 1, but that other 2 should stay at 2. Did I get that right? Looks right to me. Yeah, we're good. Okay, so let me actually fix that. think. And this 2 goes to a 1. And so what should happen is, as the column goes from 0 to 1, the height goes up by 1. At 2, it goes up by 2. And then it comes back down. And then so you get this triangle wave type shape. I'm only doing it based on the column. So you can imagine like this wave shape. That's what the terrain is. And so right now, all of the terrain is walkable. But as you walk across that terrain, you're actually changing heights. So we need to build this kind of bottom up. We need some helper functions here. Let me just make a post here. Let's do this. Okay. The first thing we need to know is can somebody get to, what squares can they get to from their current square, and how much does that cost? At the moment, we'll make all the costs 1, but that's something that we're going to need. So let's create that function. Do we have there's a get chord, oh, there's an adjacent chords. So the adjacent chords, let's see if we can remind ourselves who uses this. Adjacent chords is used when we're getting all the places a person can walk to, and it's used when we're getting all the squares adjacent to a target. That's all the squares that a person can kind of like melee hit to. So we're going to change this a bit. And because there's sort of 2 different use cases, I think I'm going to have to adjust this a little bit. For now, we'll assume that if you can jump 1 square up or down, then you can also hit somebody 1 square up or down. So yeah, let's call this adjacent movement chords. So we want to know, given a point, and we need to know the unit. Now, that matters. What are the points that they can move to? I guess in this game, like going back to the screenshot here, yeah, you always kind of move. You don't really jump. I think there is actually jumping in this game, but we won't worry about that for now. So you always move 1 square adjacent, but then you also have to look, like, can I drop down a square or go up a square? So a lot of this stays the same. We have our new coordinate, but this is going to be different. The new coordinate might not be on that point on the floor. So let's add a bit of asserts here. So if we added this walkable chords, adjacent. So, you know, we only want to do adjacent coordinates from a walkable point. So let's make sure we're not making that mistake. Then we go around and we say, you know, find all the walkable coordinates that are, you know, at that location and within 1 of the floor. Let me think if there's a faster way to do that. I think because walkable chords is a hash set, I think the fastest way is just to also do another for loop here. Fmod. And let me get the stream up on my laptop so I can monitor the chat here. All right, I have all the chat there. Okay. And we want to see if there's a walkable chord there. This is going to be point.floor plus fmod. You want to make sure it's in bounds. Actually, you don't need to do this anymore. This is actually simpler because if it's not in bounds, it won't be walkable. So if this dot walkable towards dot contains C. That's nice. Then you can move to it. And so this will automatically handle the, stepping up, stepping down. Now getting the adjacent coordinates to the target, that actually depends on, oh wait, we forgot to take into account that some units have different jump heights. So let's take care of that. This actually needs to be -1 times unit dot type dot jump height. There we go. Now we need like an adjacent attack coords. And I think adjacent attack coords, it's going to be very similar. I'm going to change this a little bit. I'm actually going to make this something I pass in. And then I'm going to make an adjacent attack coords be the same thing, but with a jump height of 1. Maybe in the future, people will be able to attack things that are further away. I'm not sure, but for now, we'll keep it simple. And so we want to move adjacent to, let's actually change that language a little bit. Move to attack range. Yeah. Cool, there's a person watching, unless that's me. Welcome, if you're watching. Feel free to say something in the chat. Okay, so move to attack range. Let me just, there we go. Move to attack range. Adjacent attack coords. Actually, interesting. We, if we're an archer, this might be that place where we handle that. Move to attack range. Hey, how's it going, BJ? We actually need to move to where we can attack a point. Hey, John. Move to attack range. This says move to where we can hit somebody. Adjacent attack coords. We almost need to know, like, what squares can hit this square. I'm going to actually just change it to attack coords. I'm going to do something a little bit different. Because it now depends on the unit doing the attacking. Yeah, this actually gets kind of tricky. So now even the row and the column will be more or less depending on if we're, an archer or something like that. So we actually need a horizontal range. And this used to be not allowing diagonal. Because you can't swing the sword diagonal. But if you're firing a bow or something, it really doesn't matter. So let's make that a parameter. Actually, let's just do this for now. I want to get this up and running, so I'm going to make kind of a bunch of shortcuts here. So we're going to allow diagonal attacking if your range of your attack is more than one. If okay, so these are all the squares. I'm going to change this function again. This has become kind of like an attack coords thing. Yeah, well, let's see, horizontal range. And then the jump height, that's going to be the vertical range. Let's actually rename that. Okay, so we're going to find, this is going to give us all the places we can be and attack this location. So this is going to give us a bunch of places, especially for the archers. If you're already at one of those places, you're done. Otherwise, get all the places you can go to. And okay, this, we probably need to go to the closest one. I think it's going to be weird if we don't do that. So we're going to change this a little bit. So we're going through all of our adjacent coordinates. If there's a place we can move to, then we're going to do it. Okay, in this case, we want the one that's closest to the unit location. Okay, so we did a lot of complicated stuff. Let's break this down. We're trying to move into the attack range so we can hit somebody. We get all the places from which we can attack that target. We check if we're already there. If we're there, we're done. If we're not there, we have to move there, get us all the places we can move to. I'm gonna have to, that's gonna be important. Get all the places we can move to. If one of the places we can move to, okay, then we're looping through all of the places where we can hit the target. If we find one that's a place we can move to, we check the distance. if we end up with a place we can move to where we can hit, which is the lowest distance, then we move there so we can fire our bow or what have you. Otherwise, we're going to get as close as we can. We're going to loop through all the places, and we're going to get the nearest one without this extra logic. So this is basically the same as this, but without the if statement. So we'd rather move to a place in attack range, even if that's further from us. Even if that's further from the target than this. Yeah, so this is all looking good. There's a couple of things that we need to figure out. Just going to the place that's the nearest distance. Distance might not. We want to do the distance in the game space, not really. This used to be just the Euclidean distance or the chess distance, but now we need that to be something more complicated. Let's actually see who all is using this. We have horizontal distance, vertical distance. The only places where we're using this distance function, it looks like it's just right here. So yeah, I'm going to rename this. So we're going to call this movement distance. And this is going to take into account the jump height. And that we're going to have to implement. So we'll get coordinates in range, get all the coordinates we can move to using the jump height. So let's take a look at this. This is the first one we're going to have to fix. Right, so adjacent coords changed, right? So we renamed that to something. Adjacent movement coords. And now it takes the horizontal range and the vertical range. In this case, you're only ever moving one square at a time, but the vertical range is that jump height, which is that new argument we just created here. Okay, so that clears that up. Movement distance, we have to implement this. This is going to be complicated because it's based on the map. So we actually, this is no longer some trivial function we can put inside of coord now. So we need to know, I think this was unit.location, yeah. This needs to be something inside the map function now. So movement distance is the distance, the number of steps it's going to take for somebody to move to that target given their jump height. Okay. And so this is going to end up being a BFS as well. Wonder if we can make some kind of more generic. So we have this BFS, get coordinates in range. This question is really like a get range, get the smallest range between these two things. Um, yeah, I'm gonna start by just copying this BFS. In the future, we might want to make a more generic BFS, but I'm not 100% sure. So for now, I'll copy it. Here's all places we visited. We start at the source. We pull the item off. We get the distance traveled. If we've been here before, skip it. Otherwise, add it. If we're at the destination, and we return the distance traveled. Otherwise, we get the adjacent chords. We have the jump height. This we don't need anymore. So yeah, very similar to what we had before. If you just can't get there, that's interesting. Like imagine somebody's on the other side of a river and you can't get to them. For now, I'm just gonna throw an exception. What am I throwing for everything? I forgot. It's like out of bounds exception or something. Invalid operation. I have no idea if that's the right exception to be throwing, but it really doesn't matter. Could not find a path from source to dest. Okay, that looks good. Okay, what's not implemented? Unit.location.nearest. Find nearest targetable enemy. That's interesting. Find nearest targetable enemy. So nearest targetable enemy needs to be based on the distance. Fun fact, tuples have a shorthand syntax type. Really? That's interesting. So the nearest targetable enemy is the nearest person that, it's the nearest person in terms of distance. Oh, but not necessarily, right? Because if you're an archer, you might be able to shoot somebody who's, you know, like up on a wall. It might be really hard to get to that person, but you could shoot them. So it's really, it's actually the nearest, it's the, you know, we have those spaces of like, here's the envelope of spaces that you can hit someone from. It's actually the nearest one of those. So what does this function do? Why is it not here anymore? So I somehow got rid of nearest coordinate. I think because okay, so we actually need to know, okay, we need to know the distance to a set of places. So it's going to be a little different than this. Where is our function we just wrote? Movement distance. Yeah, so this actually needs to take potentially a set of places and give us the shortest distance. Same kind of thing. I'm going to make a copy here because I just feel like we're going to be changing this and specializing it, but I'm going to do shortest distance. And we're going to do list, actually hash that. And the big difference is if destinations contains current point. I kind of feel like, yeah, I'm actually just going to change this. New. Can I create it just from one item? How would that even work? I don't think that's gonna work. Does this need to be like something like this or something? No. I haven't found out a way to do this in line. That's like the second time I've been hit with that. John, if you know a way to simplify this so that I can just inline create a hash set from a list literal, let me know. Okay, shortest distance. Okay, so getting back to here. So this is okay, I'm going to change this a little bit. Call this target to make it a little easier to read. Oops, went too far. Okay. So yeah, this needs to be different. So what we care about is what is the shortest distance. So target attack, oops, bar target attack locations, attack cohorts. Interesting, we need the unit now. And I think that's because we need the jump height of the unit, right? Or we need the yeah, the range of the unit. So this is going to now be unit. Call this attacker. So now this says, given this attacker, get all of the coordinates that we can hit this target from. And these are the target attack locations, and then get the smallest distance. Distance to attack location, shortest distance, attacker dot location, target attack locations, attacker dot type dot jump height. And target attack locations needs to become a hash set. Okay, so we're saying a little comment here. Get as close as we can hit the target from. Get the shortest distance to one of those squares. Okay, this looks good. Check here. Okay, so we don't have any. Oh, there's still a red line here. What's going on here? Can't find path from source to. Ah, okay. Is there like a to list? There's, yeah, to list. Perfect. Battle. Okay, so now let's kind of step through this. So step, goes through each team. Team goes through each unit. Step unit. Okay, now this takes in the whole unit. Find the nearest enemy. Move to attack that person. If you are... okay, so now this needs to be more complicated. This basically needs to say, can you attack that square from that square? And so we have a function for that, right? Attack chords is our function. If this.map.attack chords nearest enemy.location unit contains unit.location. Basically, if we're in a location that we can attack the enemy from, then you attack. Okay. Okay, I think this makes sense. Yeah, lots to wrap our head around, but let's run it and see what happens. All right, let's see. Try to get adjacent chords to a non-walkable chord. All right, let's dive through this. So, okay, let's actually put the debugger here. Okay, so it's Buddy John's turn. We want to find the nearest targetable enemy. To find the nearest targetable enemy, we have somebody who's targetable and get all the squares we can hit them from, which means get all the squares we can hit someone from is the same as saying okay, hang on. Get all the squares we can hit somebody from is the same as saying get all the squares that we that are adjacent in movement space with that range. If this, oh, right, okay. I know what's wrong. The problem is when we created our people, we created them in coordinates that are not walkable. That's a problem. See what I'm saying? Because here is our new map. And so we need to find, these coordinates need to be in our height map. In fact, let's put anytime you get an error like this, you should always protect yourself against getting that error again, because otherwise you'll just keep hitting it over and over and over again. So I'm going to do something here that's kind of important. Where is entity? Here. Every entity should be in a walkable location. It's tough without having the map as a global, which I really don't want to do. It's tough to enforce that. One thing I could do is I could have like a reference. Is there a way to make a reference that won't get serialized? That might be the way to go here. Yeah, if the entity had a back reference to the map, then I could do this. So let's see. C# JSON skip field. Is there a way when how do I exclude a public property of it? JSON ignore. Interesting. Let's try it. Okay, I think we need this, right? How does this work? Using, okay. Are we okay? We're not okay. Nope, that's what I had before. Let's try this. Hey, okay. So now when I create an entity, I'm going to have a reference to the map in it. Oh. Okay, so getting back to my program, I create these guys. I have a back reference to the map. Okay, now in unit, I need to do map, base, map. Okay, now they're all happy. Okay, so now I can do this. In entity, I want to make a getter and a setter. How do I do a default? C# property default get. Is there something called? Okay, so I think I can do get. But then I want set to, I want set to be more complicated. Oh, I need like a shadow variable here now. Okay, is that good? Okay, cool. Now when I set the location, I also want to make sure it's walkable. Any bug you have in your code, you will have again. Like every bug that you see, you need to fix like fundamentally. There. So now when I run it, I should hit this exception right away. Bink. There we go. Perfect. Perfect. Okay. Now. Okay, so this guy's at 0, 0, 0. But this soldier is not correct. So this is going to be, well, let's just print this whole height map. Okay, all right, good times. Let's try and print it as an array. Empty, that can't be right. Okay, let's just print each chord as we get it. Okay. Row 0, column 0, floor equals 4. We should make, actually, I have a better way of doing this. Let's just make a function that puts someone on the ground. Put them on the ground. Map dot, we'll call it raised to nearest floor. To nearest walkable floor. Okay. Okay, now let's implement this. Raised to nearest walkable floor. Da, 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 da. So while chord dot, wait, how would this work? While true, I guess. If this dot walkable contains chord, return chord. Else, if chord dot floor, let's just say chord equals chord dot shift. We'll have to implement that. If chord dot floor equals this dot floors, throw an exception. We've gone too far. Not find a walkable floor on this chord. Yeah, that looks good. Okay, let's make this shift function. Okay. Let's try it out. Okay, well, we're doing something. Oh, okay, this is looking good. Let's see. So on John's turn, John is an archer. He moved from 0, 0 to 0, 3, but he can't attack this person who's at 0, 10. That's right, right? Soldier moved. Wait. Oh, in these games, people don't move diagonally. Oh man, yeah, that's a mistake actually. So adjacent movement chords. Allow diagonal. get chords in range. Actually, this should be okay. Okay, so soldier's turn. He moved from 0-10 to 0-7, but couldn't attack because it's not close enough. On John's turn, he doesn't have to move. That's a good sign. So basically, he's at 0-3, and he hit the soldier who's at 0-7. But his range, I thought, was only 3. There's some off by 1. Oh, no, the range is 4. Okay, we're good. So he just hits him right away, which is nice. I mean, I guess even smarter would be to take a step back. Not in this case, but like if you're right up to somebody, take a step back and then hit him. But for now, I mean, it's good enough. And then the soldier was able to close the distance and hit John and killed him. Oh, we don't tell. We need to print something when someone gets killed. Let's do that really quick. Actually, we can just, don't we have like a targetable? Yeah. Oh, am I editing? Oh, I'm editing unit type, damn. Okay, hang on. Let me fix all that. I'm doing the wrong thing here. Totally messing this up. Health, this is actually wrong. Actually, we can just say if there we go. Oh. We need to know what the old health was. Okay. All right, this will be some nice, oh, what did I do wrong? Oh, whoops. Okay, we took -2 damage at the beginning of the game. That's pretty funny. So that is because of this. It's your turn, you move, this guy moves. This guy takes 1 damage, but he's still alive. This guy hits him for 2 and knocks him out. Okay, so we're good. So, yeah, I mean, we should definitely test some kind of really kind of wild scenarios. I almost wonder if we should kind of move on to the level editor and find a way to get some levels implemented. So we have this thing in Godot called a grid map. At the moment, we'll just keep it really simple. take these terrain cubes, and let's just make a, how do I pan around here? Oops. Yeah, I'm not. Oops. No, okay, I'm still getting my handle on this. Here we go. Whoa, okay. Okay, I think I understand it. So it's a right-handed coordinate system. So Z is facing towards you, which is kind of interesting. But let's just start by making what is that up? 2, 3, 4, 5. Yeah, 5 by 5 little grid here of forest tiles. We need some way to basically export this level. Yeah, this is my first time using Blender, so let's go. We'll rename this actually. Call this like level. Can I do spaces? Call it level editor. Maybe battle level editor? Level editor is fine. Oh, what did I just do? Oh, okay. So we need a program that runs that will take a look at this grid map and turn it into something, probably JSON, that we can then ingest here. So let's see. How is this going to work? Level editor. We have this grid map. I guess we need a, whoops. Set as scene instance. New script. C#. Template default battle. Call this dump terrain. Okay, so we have this script called when the node enters the scene tree for the first time. Oh, so we have to somehow attach this script. Oh, interesting. So we can attach this script to that grid map. Let's try it. And then, is there like a print? Cool. You might like this. All right, let's see it, Flaky Brains. We don't like it. Sorry. Okay. Wait, what? Dump terrain.cs. Why is it asking me to save it as something? Okay, I'm not sure what that is, but all right. Level editor. Oh, it made a new scene somehow. Okay. Okay. So this should hopefully print something. How do I run this? Oh, there's a little thing up here. Play the project, play the scene, play the custom scene. All right, let's play the scene. Failed to build. All right. The SDK could not be found. Oh God. NuGet packages, Godot.NET SDK. Oh God. All right. Oops. Godot mono install SDK. Compiling with mono. Run it from the mono command line prompt. Okay. Yeah, if this starts to get like a slog, I might just turn the stream off and do some of this on my own time, because I don't want to waste y'all's time on this. Okay, yeah, I'm going to shut the stream off. I'm going to figure out how to get Godot to compile some basic stuff, and I'm going to get this little level that we created here. It's a very simple level. In fact, I might add a little bit more just to make it a little bit more complex. How to get this level that we created into our code. Once I do that, I'll come back, because I have a feeling that this is going to go pretty slow, and I don't want to waste y'all's time.